So, good day everyone. We are Group 4 and I am Janice Catapang and I am here with my group mates.
I'm Aaron Jamiel de Guzman.
And I am Gracie Cortez.
And today we're gonna talk about our Project 2.
A
So, for our first objective is to convert truth table, Boolean expression, and logic function to its simplified combination circuit. And lastly, to examine which combination or sequential circuit to apply in the project.
So, for the definition of terms, registers, a flip-flop is a 1-bit memory cell which can be used for storing the digital data to increase the storage capacity in terms of number of bits. We have to use a group of flip-flops, such as a group of flip-flop is known as a register. The binary data in a register can be moved within the register from one flip-flop to another. The registers that allow such data transfer are called shift registers. There are four modes of operation of a shift register and are follows. So here are the modes of operations. The serial input, serial output, or the SISO. So let all the flip-flop be initially in the reset condition, i.e. which is Q sub 3 is equals to Q sub 2 is equals to Q sub 1 and Q sub O, which is equals to 0. If an entry of a 4-bit binary number 111 is made into the register, this number should be applied to the D sub in bit with the LSB bit applied first. The D input of the which is shown in the figure is connected to serial data input D in. The output, which is also shown in the figure, is connected to the input of the next flip-flop, and so on. So for the next mode of operation is the serial input parallel output, which is the SIPO. So in such types of operation, the data is entered serially and taken out in parallel fashion. Data is loaded bit by bit. The outputs are disabled as long as the data is loading. As soon as the data loading gets completed, all the flip-flops contain their required data. 4 clock cycles are required to load a 4-bit word. Hence, the speed of operation of SIPO mode is the same as that of the SISO mode. So the next, the parallel input serial output, which is the PISO. Bits are entered in parallel fashion. The circuit shown below is a 4-bit parallel input serial output register. Output of previous flip-flop is connected to the input of the next one via a combinational circuit. The binary input word B sub O, B sub 1, B sub 2, and B sub 3 is applied through the same combinational circuit. There are two modes in which this circuit can work, which is the shift mode or load mode. And then the last one is the parallel input and parallel output, which is the PIPO. In this mode, the 4-bit binary input B sub 0, B sub 1, B sub 2, and B sub 3 is applied to the data inputs of D sub 0, D sub 1, D sub 2, and D sub 3 respectively of the 4 flip-flops. As soon as the negative clock edge is applied, the input binary bits will be loaded into the flip-flop simultaneously. The loaded bits will appear simultaneously to the output side. Only clock pulse is essential to load all the bits. And here it is, as shown in the figure. Aaron?
So for the definition of terms, a counter is a device which stores and sometimes displayed the number of times a particular event or process has occurred. Often in relationship to a clock signal, counters are used in digital electronics for counting purpose. They can count specific events happening in the circuit. Next slide. So for the flip-flop, JK flip-flop is basically a gated SR flip-flop with the addition of a clock input circuitry that prevents the illegal or invalid output condition that can occur when both input S and R are equal to logic level I. Due to this additional clock input, a JK flip-flop has four possible input combinations: logic I, logic O, no change, and toggle. A symbol for a JK flip-flop is similar to that or of an SR double latch as seen in the previous tutorial except for the addition of a clock input. So for the D flip-flop, it is used as a part of a memory storage elements and data process as well. D flip-flop can built using NAND gate or with NOR gate due to its versatility. They are available at IC packages. The major application of D flip-flop are to introduce delay in timing circuit as a buffer, sampling data at specific intervals. D flip-flop is simpler in terms of wiring connection compared to JK flip-flop. So here is the representation of a JK flip-flop with their respective input and output. Next, so here is the representation of a D flip-flop table with their input and output binary number.
So, for the presentation of our simulation, first I'm going to discuss about the counter. So, for the counter, part of the project, we use the JK flip-flop in the simulation process. So, I'm going to first simulate it. Using a 4 Hz frequency, tick frequency, and then I'm going to click enable. So, in the simulation process, the clock was used in order to run the JK flip-flop. In terms of the mode of operation, it can be seen that the parallel input and parallel output or PIPO was used. So, in order to start the 180 seconds, a 4 Hz frequency tick was used. And in this mode, a 8-bit binary input was used. During the enable condition, it triggers the JK flip-flop to alter the transition between the positive and the negative phase of the transition of the clock. Then, the input at the first JK flip-flop will be the input to the next one, thus creating the 180 counter. So, for the
So this is for the D flip-flop of our project. So the D flip-flop is also known the delay flip-flop. The D flip-flop captures the value of the D input, which is in the left side of the circuit, and the D input at the defined portion of the clock cycle, such as the rising edge of the clock, but it captures the value and becomes the Q output. So the purpose of the D flip-flop is to capture the data and to transmit the data to the output. And at other times, the output of Q does not change. So that's why it's called the delay flip-flop. Okay.
so next for the main.
Okay, so for our main circuit, we are now given this circuit, which is our project 1, and we only added the register and the counter. So to start the circuit, we first go to the simulation. Then after 180 seconds in our requirements, the display for the temperature is 15. So going back, pindutin mo yung ink, tapos reset mo. So if you reset, then you press the increase, the value will increase. Then if you press decrease, then you reset. From the value of 15, it will decrease to 14. That's all for our project 2. Good day, everyone. And thank you. I am Janice Dylan Catapang.
I am Gracie Cortez.
I'm Aaron Jamil Guzman.
And we are group 4.